Hi guys, good evening everyone. Hello everyone, how are you all? I hope everyone is doing well. So, the topic that we are going to do today is the best model of an atom that we have till now and which we are using also. Yes, that is quantum mechanical model of an atom, because Bohr model of an atom was having certain limitations, and what was those limitations, we'll be also discussing that. So what you have to know, a very simple thing, that due to the limitations of Bohr model of an atom, we have to introduce a new model of an atom, which is nothing but quantum mechanical model of an atom. Okay, very good. So we'll be discussing about it, but yeah, before that, all of the students who are new on the platform, they must be curious to know about their educator. And talking about myself, I have enriched 5 years of experience in all many online and offline reputed institutes. And yes, I have done my masters from NIT Warangal and bachelor's from Delhi University. Okay, good evening Abhishek. So you were able to see the notes, and it was helpful for you. Good. So yes, talking about myself, I have done my masters from NIT Warangal and bachelor's from Delhi universities. I have cracked IIT CHEM, CSIR NET and GATE, and yes, I have given best ranks through my students in NEET and JEE Mains. I have given a good amount of selections in NEET and JEE Mains, and I am a plus verified tutor. So this is about myself. Now you can join my Telegram channel by either scanning the code or by using the link. Yes, you can join the Telegram channel, guys. And talking about the special classes which occurs on our Unacademy platform, so there are the special points about our special classes. What are those? You can learn from your favorite educators for free. You can engage with the educators via polls. You get clear your doubts in the special classes. Okay, very good. Thank you so much, Abhishek. I'm happy to hear that it was helpful for you. Now talking about the classes, guys, so we'll be having a class today, which is at 6:30 to 7:30 p.m. guys, which is on hydrogen bonding. So today there is a class, and we have already discussed classes like on the topic of modern periodic table and numericals on atomic structure. So if you want, you can go and access all these classes. Okay, very good. Now talking about, yes guys, what are the good things about our Unacademy subscription features. So the first thing, you can learn live from the comfort of your home. Yes, you get unlimited access to all the courses. You are going to learn from the top educators of India on one platform itself, and there will be a regular doubt clearing sessions. We'll be doing the exhaustive coverage of syllabus, and there will be complete mentorship and guidance throughout. Yes, you will be getting the study material in the PDF format as well, and you will be getting the practice tests. You will be having access to the live test series, guys, and you will be getting the batch courses depending upon the requirement. So actually it's very beneficial. Now Unacademy is celebrating the achievers of ISC class 10. I hope all of you guys are also going to get a really good marks in your respective standard. Now there is a very important news, guys, that Unacademy unlocks, yes, just got bigger, because you are going to save up to 41% if you will be enrolling today before 12 p.m. for our plus course classes. What you have to know, guys, yes, you will be able to, yes, save 41% amount. So for that, what you have to do, you have to use my code, which is MRIS10, and you will be getting instant 41% discount, guys, because you will be getting 20% discount along with that 6 months extension, which makes it 41%. So isn't it great, guys? Yes. So all of you, those who want to enroll for our plus course classes, make sure you're doing it today before 12 p.m. So last class, what we discussed Bohr's model of an atom. Yes, very good. What we discussed Bohr's model of an atom, and in the Bohr's model of an atom, what you have to know, guys, there are some limitations for it. Yes, correct, Abhishek. So this is the code, and if you'll be using it, you will be getting instant 41% discount, and this offer is valid today till 12 p.m. So this offer is valid today till 12 like midnight, so make sure you are enrolling it today itself. So now talking about limitation of Bohr model of an atom. So what are the limitations of Bohr model of an atom? So the first one which we have to know, that your Bohr model of an atom is applicable for only, yes, species which contains one electron. So they are applicable for it is applicable for uni-electron species, right? It is not applicable for multi-electron species. If we talk about the hydrogen spectrum, the Bohr model gave, which we discussed in the previous class, what it said only regarding the hydrogen atom, and those species which has one electron just like hydrogen, they also shows, yes, they also shows the same way, like all the formulas that we use, we can use even for them as well. But if you have a multi-electron species, you cannot utilize it. So yes, the first limitation is what, guys? It fails to explain. What is that? It fails to explain the atomic spectra for, it fails to explain the atomic spectra for what, guys? It fails to explain the atomic spectra for elements containing more than one electron, for elements containing more than one electron. So one of the limitation. Another limitation was that it was not able to explain, so the Bohr's model of an atom was not able to explain the splitting of spectral lines in magnetic and electrical fields. So what was seen, the lines were showing splitting, like in the hydrogen spectrum, the lines that we observed, Lyman series, Balmer series and all, so they were getting splitted. What you can relate in the presence of what, in the presence of electrical and magnetic field lines. So why they were getting splitted, so that was not able to explain by, yes, by your Bohr model of an atom. So what we can relate, hi Harshit. So what it do, it fails. So what we are discussing limitations of Bohr model of an atom, and then we'll be also discussing, yes, limitations of Bohr model of an atom we are discussing, and then we'll be learning about, yes, so it is Rishita. It's little, her name, it is little difficult to pronounce. It is Rishita, right? H is silent. So Rishita, we are discussing about limitations of Bohr model of an atom, so that we can go towards quantum mechanical model of an atom. Okay, so the first one we understood, it fails to explain the atomic spectra for elements containing more than one electron, like helium, lithium, beryllium and so on. Correct, it's Harshita. Okay, now what do you have to know, the another, yes, oh, it's not, H is not silent. Okay, so it's Harshita only, right? Now what we can relate, very simple, it fails to explain the splitting of, it fails to explain the splitting of lines, splitting of spectral lines in the presence of, splitting of spectral lines in the presence of, magnetic field lines, in the presence of magnetic field lines, which is called as Zeeman effect, right? In the presence of magnetic field lines, which is called as Zeeman effect. Okay, and electrical field lines, which is called as Stark effect, guys. In electrical field lines also, the spectral lines get splitted, which is called as what? Stark effect, guys. What is that? Stark effect. So this is the two main limitations of Bohr model of an atom. Now talking about the third limitation, yes, what was that? Which helped us to build the quantum mechanical model of an atom. So the third limitation, it did not included the results from, it did not included the results from, yes, exactly, because remember Abhishek, chemistry is one of the subject which is interdisciplinary, means it is interconnected to every branch of science, it is interconnected to everything. So every subject you can understand in terms of chemistry, right? Like in terms of like not completely, but there are some concepts which are always related, right? So yes, your chemistry is related with physics also, with biology also, yes, with the whatnot, like everything. So you can relate that. Now, what we can understand, it did not included the results from where? From two of the scientists, yes, who gave us a very good results. What are those? So it did not include the results from Heisenberg's uncertainty principle. Heisenberg's uncertainty principle and yes, Heisenberg's uncertainty principle and the dual nature of matter. Heisenberg's uncertainty principle and dual nature of matter. So that was also is one of the limitation. What is that? That it did not included the results which we got from two of the scientists experiments and what results they gave. Like one of is Heisenberg's uncertainty principle, another is dual nature of matter, and that we'll be learning about Broglie equation. So yes, it didn't your Bohr model of an atom did not included it, and as well as your Bohr model of an atom was not able to explain the ability, it was not able to explain the ability of, yes, the ability of an atom to form, yes, the ability of an atom to form chemical bond. So it was not able to explain that also. So that is why there was the limitations, right? So these and all were the limitations of Bohr model of an atom, and which gives rise to what? The modern structure of atom, which is also called as quantum. In my class 11, I don't know when my session finished. We get limited knowledge of chapter, ma'am. Okay, Abhishek. So here we'll be learning every topic in detail. So because you can relate that in ISC board, it is little tougher and it is a little detailed version than CBSE board. So if we'll be learning here in the ISC board all those chapters, you will get to know that for every concept you will be getting in-depth knowledge, and because of that you will be able to relate it easily. Okay, so it's going to be really helpful. Now talking about here, what we can understand, what are the limitations of Bohr model of an atom, we have understood because there was limitation. So due to that, yes, due to that the new model came into the picture, which is modern structure of atom or the quantum mechanical model of an atom. So modern structure of atom, which is also known as quantum mechanical model of an atom. Quantum mechanical model of an atom. Now what is quantum mechanical model of an atom? Yes, so this quantum mechanical model of an atom, it is based upon two results, right? So it is this quantum mechanical model of an atom is based upon two results. So it included, yes, it considered two results. By that we got all the things which were not explained by Bohr, yes, explained in a detailed manner. So what we can relate quantum mechanical model of an atom, what it did, yes, so for this two results were considered. For this, what you have to know, two results were considered. What were those? Yes, one is your dual nature of matter. So dual nature of matter, in that specifically we'll be discussing about what, guys? Dual nature of electron. So just like our wave, which shows both the nature, particle as well as wave nature, your electron, your matter, all the particles, moving particles, they also shows a dual nature. So two results were considered to build a quantum mechanical model of an atom, guys. What were those? First one is dual nature of matter, and the second one is Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. So let's just understand about both of them one by one. So talking about dual nature of matter, or like specifically we'll be discussing about electron. So what is that? Dual nature of electron, or you can also relate with the matter, like any moving particle we can relate that. So who explained us about it? So there was a scientist named, guys, de Broglie. There was a scientist named de Broglie who helped us to understand the dual nature of electron. So what he said, a simple thing, matter. So in matter specifically we are considering electron, like radiation. So what it do? Matter like radiation shows what? Shows dual behavior. That is what? Dual behavior. And what is dual behavior, guys? Yes, dual behavior, and that is nothing but particle and wave nature. What is that? Particle and wave nature. So this de Broglie said that, and what he said, just as a photon, like photon contains both momentum as well as wavelength, because wavelength is due to what? Due to the wave nature, and momentum is due to the particle nature. So he said that just as photons or the radiations contains momentum as well as wavelength, same way your electron also contains momentum as well as wavelength. So what it said? Yes, it said that just like photon, yes, just like photon, electron also possess, yes, electron also what? Electron also possess or contains, yes, wavelength as well as momentum, contains wavelength as well as momentum. Correct, everyone? Wavelength as well as momentum. So contains, or we can write possess. That also is going to be a better word. So wavelength, electron also possess wavelength as well as momentum. Wavelength as well as momentum. Now how we can relate with it? It's very simple. You know that when there is a wave nature, so for that we can define energy is equal to h mu. Very good, Abhishek, right? So when we have a wave nature, we can explain E is equal to h mu, right, which we can also write h c by lambda, wave nature. And if we consider particle nature, you must have studied that in the physics, that E is equal to mc square. So that is due to particle nature, correct? So if your electron contains both, can I compare both of these equations, guys? Yes, tell me. Can I compare both of these equations? And because of that, what I can write? Can I write comparing equation? H is Planck's constant. Very good. So comparing equation 1 and 2. What we can relate? E is equal to h mu. What is h? H is Planck's constant. What is mu? What mu is frequency. What is c over here? Yes, c is nothing but, guys, speed of light. Everyone, yes, tell me. C is speed of light. Very good. And lambda is wavelength. Correct? Very good. Now here what is m? M is mass and c is velocity. Correct? Very good. That's what we can relate. So if I'll compare both the equations, what I can get? I can compare. Absolutely correct, Abhishek. It is going to be 3 into 10 to the power 8. That is speed of light. So if I'll be comparing equation 1 and 2, I can compare h mu is equal to mc square. Correct? I can compare h mu is equal to mc square, which I can also write as hc by lambda. So I can compare any of these things. Now what I will get? I can compare it clearly that hc by lambda is equal to mc square. So what I can do? I can take this lambda. Yes, I can take this lambda over there. So what I'll be getting? I'll be getting very simple. H upon lambda. So here it is c here. So what I'll get? mc square divided by here c will come. So you will get h by lambda. Yes, h by lambda is equal to mc, and what we can relate? H upon mc will be equal to lambda. So what I got? I got the expression for wavelength. How you can find it out? The wavelength. Wavelength you can find it out. Planck's constant divided by mass into. Okay, Alka, I'll explain it once more. No problem. So what we are discussing, Alka, we are discussing a very simple thing, that how we got to know about quantum mechanical model of an atom. So Alka, quantum mechanical model of an atom is based upon two results. What are those? One is dual nature of matter and another is Heisenberg's uncertainty principle. Okay, now what this dual nature of matter says? So basically in dual nature of matter we'll be discussing about dual nature of electron. So there is one scientist named D. Broglie. What he said, just like the radiation shows dual nature, that is particle and wave nature, even your electron, yes, so electron also shows both nature. What is that? The wave nature as well as particle nature. Okay. So according to the wave nature, we can define that energy of the radiation is going to be equal to h mu. H is the Planck's constant, mu is frequency. Correct, Alka? And we can write frequency as c by lambda also. So this is the expression. Now according to the particle nature, we can define this equation. E is equal to mc square. M is mass, v is velocity. So this is according, like this equation we study even in physics also. So according to particle nature, we can write E is equal to mc square, because they both equations are equal to E, like they both are telling us energy. So I can compare both these equations, comparing equation 1 and 2. So what I can write? I can write hc by lambda is equal to mc square. So I can write h mu is equal to hc by lambda, which is equal to mc square. Correct? Very good. So Alka, now what I'll be doing, I'll be comparing that hc by lambda is equal to mc square. So what I did, if I take this c down, what I will get? I will get h by lambda is equal to mc. So I can write lambda is equal to, if I can take this mc down now, so I can write lambda, which is wavelength. Yes, lambda, which is wavelength. How you can calculate it? You can calculate it with the help of Planck's constant divided by mass of the particle. Like specifically we'll be discussing about electron, and speed or velocity of light. Correct? Understood that, Alka, Abhishek, everyone? So what I got? Okay, Pranjal. So what you can understand here is very simple. What we got a de Broglie wavelength equation, which is lambda is equal to h upon mc. Now we can do some variations over here. What is that? Lambda is equal to h upon mc. What is m? M is mass of electron, c is velocity of light. Now you know that this is velocity and mass. So you can relate that. Can we write? Yes. Very good. Mass of electron is 9 point. Very good, Abhishek. So what we can relate, you know that what is momentum, guys? Momentum is nothing but it is denoted by P, which is equal to mass into velocity. So I can also write lambda is equal to h upon P, which is equal to h upon mv. Correct, guys? Yes or no? So I can write lambda is equal to h upon P, which is equal to h upon mv. So P is nothing but momentum, which is denoted as mass into velocity. So I think either you can write V or you can write C also, which is going to be the same thing, just we are denoting. Now you can relate with one more thing, guys, which is very important, and many of the students, they feel stuck in that formula, that how you can compare kinetic energy with wavelength. Yes, so let's just understand that kinetic energy and wavelength, how you can compare. So everyone knows what is the formula of kinetic energy. Can anyone tell? Yes. So kinetic energy and wavelength of moving particle, how you can compare that? Let's just understand. So kinetic energy and wavelength of moving particle, how you can compare it. So tell me, everyone. Yes, you know that what is kinetic energy formula? Kinetic energy is equal to half mv square. Correct? Yes or no, everyone? So if I want to get the expression for mv, what I can do? Can I write twice of kinetic energy is equal to mv square? Correct? Yes or no? Very good. I can take this m down. Can I take it? So twice of kinetic energy divided by m is equal to v square. Now here there is a square. If it will go opposite side, it will become square root, no? Twice of kinetic energy divided by m. Yes, you will have a root in the whole thing, and is equal to, you will get v. Correct, guys? Tell me. Now this equation that you have got, yes, say equation 1. Now what you will do, this equation 1, if you will multiply both the sides, m, mass, can you apply both the sides mass? Can you multiply? So I was having this equation, guys, that is nothing but root 2 kinetic energy by m is equal to mv. Sorry, it was equal to v. This is what the equation we got by doing some simplification. This is what I have got. Very good. Now what I should do? I can multiply both the sides mass, no? Yes, if I'll multiply both the sides mass, what I'll get? So in the equation 1, what I have done, apply or multiply mass into both the sides, right? Can we do that? Yes. So what I can write, multiply m to both sides. That's what I have done. Now if I'll do that, this is m, guys. Can I write mass as root m into root m, which will give me m only? Yes, guys, this m, can I write it as root m into root m, because root will get cancelled and I will get m only? Everyone is able to relate? This is simple maths. So what you will have, you can write even this also a term, which is twice of kinetic energy divided by m. Whole thing is there in the square root. So what I can do here, I can do a simple thing. I can write even this as root. Yes, what I can do, I can write this as root 2 kinetic energy divided by root m. So this root m and root m I can cancel, which is equal to mv, correct, which is equal to mv. Now you can write, no, because this is also in square root, this is also in square root, so you can all together write 2 kinetic energy, twice of kinetic energy into m. Can I write it? Yes, all together in one root. Tell me everyone. So 2m into kinetic energy. Very good. Yes, so m is also under square root, so we can put that. So 2m kinetic energy, I can write it. Very good, Abhishek. So 2m kinetic energy is equal to mv. So can I use this equation 2 in the formula which we got for the kinetic energy? Sorry, in the formula that we got in the equation 1, that is de Broglie equation. Can I use? Yes, this is called as de Broglie equation. Okay, Pranjal, no problem. You can later on see the recording. If you have some work right now, you can check the recording later. So yes, de Broglie equation this is. So if I'll be putting the value mv, yes, so substituting mv, substituting equation 2 in de Broglie equation, what we will get? So substituting equation 2 in de Broglie equation, what I will get? I will get one more expression. So what was that? Lambda is equal to h upon mv, which is equal to h upon p. And now instead of mv, if I can put root 2m kinetic energy. So all these formulas, what I can do, I can utilize to find out the wavelength of an electron or a moving particle. Correct, guys? Clear with it, everyone? That what and all formulas are there for the de Broglie equation and how you can utilize it, we'll be learning with the help of the question. So let's just do one question over here and see how many of you will be able to do it, right? So let's just do one question related to de Broglie equation. So let's just do that. So the question first, which we'll be learning, which we'll be doing is nothing but, let's just see it. So the first question is de Broglie. The question is de Broglie. Yes, de Broglie wavelength of an electron is 200 picometer. Is 200 picometer. Okay. Calculate its kinetic energy. Calculate its kinetic energy. Abhishek, P is momentum. P is momentum, which is nothing but it is equal to mass into velocity only. Okay, Abhishek? Okay, so what they said, de Broglie wavelength is given to me, which is 200 picometer. Lambda is given 200 picometer. If I'll be writing in meter, it will be 200 into 10 to the power minus 12 meter. Correct? Very good. Now lambda is given to us. What I have to find it out? I have to find out the kinetic energy. How I can find it out? Let's just see that. So I have a relation with the kinetic energy, that is lambda is equal to h upon root 2m kinetic energy. Let's just see that. So what is that? Lambda is equal to h upon root 2m kinetic energy. Correct. This is the expression. What I have to calculate? I have to calculate kinetic energy. So what I can do? I can take this here and lambda down. Can I take that? So root 2m kinetic energy. I have taken this side and I have written h upon lambda. Correct? I'm simplifying it. Now here there is a square root. If it will go on opposite side, what it will become, guys? Yes, it will become the square of this thing, no? So h upon lambda square can I write? If I take this square root on the opposite side, so I can do the square on the opposite side. Yes, it will become square. So what you can relate, h square by lambda square it is going to be, and your kinetic energy, what you can write? You can write kinetic energy will be equal to h square divided by lambda square into, yes, 2m. Correct, guys? Very good. Now what they have given in the question, because why I simplified it, because they gave de Broglie wavelength in the question. They have given wavelength only, so asked opposite only. Correct? Very good. Yes, by squaring both sides you can get that. Absolutely correct. So like generally we say in this also, no, this manner also, no, that you take that side, it becomes the, yes, square. So if you take square root on the opposite side, it becomes square. Or you can say that squaring both sides, you will get square here and this will get removed. Very good. Absolutely correct. Now kinetic energy is equal to h square divided by lambda square into 2m. Now I have to calculate kinetic energy. Planck's constant I know, wavelength is given to me, and mass, what I'll be taking, because they have mentioned of an electron. So yes, what mass you said, Abhishek, that only we are going to utilize it and we are going to get that. So mass of an electron, we will use it. So what I'll get? I'll get the form, like I'll be using the values. Planck's constant is 6.626 into 10 to the power minus 34, yes, square, divided by, yes, divided by what you have? You have a lambda square, that is 200 into 10 to the power minus 12 meter square, and here it is going to be, yes, 2 into m. So 2 into m, 2 into 9.1 into 10 to the power minus 31 kg. So you can utilize it and you can get the answer. Correct, guys? Yes, everyone. So you just have to put the values and get the answer. I hope everyone is clear. Yeah, so you can solve it later and let me know what is the answer. So the kinetic energy which you will be getting over here, because it's a little big calculation, so you can check it later. Yes, Abhishek, Pranjal, everyone, you can check it later. And the value that you are going to get is 6.09 into 10 to the power minus 18 joules. So this is what you will be getting. Okay, clear with it, everyone? Very good. Now what we'll be discussing is, we'll be discussing the next thing, like one more question. So let me just give you one more question and see who and all will be solving this as well. I hope you got it clear. Abhishek, Pranjal, Alka, everyone. So the next question that we have is, yes, the next question that we have is, calculate the wavelength of a particle. Calculate the wavelength of particle. Calculate the wavelength of particle. Yes, of mass. Calculate the wavelength of particle of mass. They have given 3.313 into 10 to the power minus 31 kg, and moving with speed. Moving with speed. Yes, so what is your actual name? Just chill, bro. So it's a little unique name, username. So what is your actual name? Calculate the wavelength of particle of mass 3.313 into 10 to the power minus 31 kg and moving with speed. Yes, 1/2 of the velocity of light. 1/2 of the velocity of light. Okay, guys. So what is the question? Question says that calculate the wavelength of particle of mass they have given, that particle mass they have given, and they have also said that it is moving with what? It is moving with a speed 1/2 of the velocity of light. Okay, so that's what they have said, and think how you can find it out. So de Broglie equation, I'll give you the expression again, guys. Yes, but before that, let me just quickly remind all of you. Yes, Unacademy is offering 41% off, instant 41% off. So if you'll be taking the subscription of plus course classes by using my code, which is MRIS10, you will be getting instant 40% discount, and this is valid till today 12 p.m. So yes, make sure everyone you are taking a benefit of it, because only 6 hours are left. Very good. Now everyone should solve this question, and I can tell you the formula also again. What was that for lambda? Yes, lambda is equal to h upon mv is equal to h upon p is equal to h upon root 2m kinetic energy. So these are the formulas you can utilize according to what we have to calculate. So everyone think, Abhishek, are you able to find it out? How will be solving it? Tell me. Very good. So you can just directly use simply formula lambda is equal to h upon mv, correct? Everyone, what we can do, we can simply use lambda is equal to h upon mv. H we know what is the value, 6.626 into 10 to the power minus 34. Mass they have given to us in the question, correct? What is that? 3.313 into 10 to the power minus 31. Yes, they have given only 3.313 into 10 to the power minus 3.313 into 10 to the power minus 31. Yes, kg they have given. Velocity is going to be what? Velocity is going to be, yes, very good Suman. Velocity is going to be, they have said half of the velocity of light. So half of the velocity of light means 1.5 into 10 to the power 8. Correct? So you'll be using it and getting the answer. So you can use it and get the answer, which is very simple. Correct, everyone? Yes, everyone can solve it. Yes or no? So you just have to put the values and get the answer, and you will be getting the lambda. So everyone has to calculate and let me know the answer, so you can do the calculation later also. Exactly Abhishek. So you can use the formula and get the answer, and you have to tell me like this calculation you have to do, and all of you those who are here, let me know that in the next session. Okay, so what will be the answer for it? So I'll be telling you that what is the exact answer in the next session. It's just you have to put and solve and get the mathematical calculation done. Very good. Now we have understood. Very good Abhishek, absolutely correct. Oh, very good. You have written all the values only in the chat, so that's great. Now talking about the next thing, we learned what? So we understood about de Broglie equation. So if we talk about that, for quantum mechanical model of an atom, two results were considered, and what were those? One was dual nature of matter, which we understood by de Broglie equation. It is explained. Now the second one is Heisenberg's uncertainty principle. So let's just talk about it, guys. Yes, what is Heisenberg's uncertainty principle? So Heisenberg's uncertainty principle, what it is? Heisenberg's uncertainty principle. So as the name itself is saying, no, uncertainty. So what is the meaning of it? Yes, uncertainty means something is going to be uncertain. Yes, something is going to be which is not certain, and you cannot tell exactly or absolutely or accurately. Yes. So what is Heisenberg uncertainty principle? So all of you guys know that there is in an atom, electrons revolve around the nucleus in a shells. Like this is what your Bohr model of an atom said, that there are electrons which revolve around the nucleus in a definite shells or path or trajectories, which we call it as orbit, shells, or energy levels or stationary levels. So all these things were told to us in the Bohr model of an atom. Now what this Heisenberg's uncertainty principle says? It says that yes, it is impossible. What it states? It states that it is impossible to, yes, it is impossible to specify at a given moment. It is impossible to specify at a given moment, it is impossible to specify at a given moment both the position and yes, both the position and momentum of an electron. What it said, it states that it is impossible to specify at a given moment what? At a given moment both the position and momentum of an electron with absolute accuracy. So you can consider electron or any microscopic object which is a moving object, with absolute accuracy. You cannot tell, because you only tell me, guys, see what we say, we have learned that electrons revolve around the nucleus in a, say, fixed shells or path. So if it is moving only, suppose if you will check at this position, yes, you will check. So till the moment you will check at this position, this electron would have moved somewhere else, no? So it is not possible to tell exact position or momentum of an electron with absolute accuracy. You cannot tell, because the moment you will check for one position, electron will be moving to another position, and its velocity also can differ depending upon what place we have, right? Like how it is moving, because it's not required that your object will be moving like a same circular motion, right? Your electron, it can somewhat it can move little slow, then it can move little fast, or like that also it can move. So what it explained us, the Heisenberg uncertainty principle, it said that it is impossible to specify at any given moment both the position as well as momentum of an electron with absolute accuracy. You cannot specify it. And this Heisenberg, he was very intelligent, because he gave a mathematical expression for it. He gave mathematically what you can relate, always the change in position and change in momentum, right? The product of that is going to be greater than and equal to h upon 4 pi. Now many of the students, they get confused with the sign of it, and in the questions what they do, they choose a wrong answer, because they mention delta x dot delta p less than and equal to h upon 4 pi, because you get confused with the sign, no? So I'll be telling you one way you remember that, because here you have two things, no? So delta x into delta p, like that. It's a very layman thing to remember, but yeah, so that you won't forget the sign. So there are two things over here, and here there is only one thing. So what you can relate, two things product obviously will be greater than or equal to one thing, like that you can relate. And here you are multiplying, here you are dividing. Okay, so what you can relate, what it said. Okay, so it's good, no? Sometimes in between, because you're sitting only, so it appears to be like I'm dancing, so that's good. Okay, so because you're sitting at one position, it's good. You're moving your hand, right? And like if it's looking like I'm dancing, so I hope like I was actually dancing. Yes, because it becomes a little difficult when you have a long hours of classes and you're sitting on the chair and just teaching it, right? So online classes, they have a lot of benefits, and like little they have limitations also. So delta x dot delta p is greater than and equal to h upon 4 pi. Okay, this is the expression which it gave. Now what you can relate, mathematically we got this expression. Now you know that momentum is equal to mass into velocity, correct? Can we write it? Mass of an object cannot change, but its velocity can change. So we can write delta v is equal delta p is equal to m dot delta v. M is the mass and v is the change in velocity. So change in momentum, you can find it out, mass into change in velocity. Correct, guys? Change in momentum is equal to mass into change in velocity. Very good. Now what we can understand over here, if I got it, can I use it, this relation, so the equation 2. So using relation 2, equation 2 in equation 1, what I will get, using equation 2 in equation 1, what we can understand here, because change in momentum, we can write mass into change in velocity. So if I can write mass into change in velocity, so in delta P I can write m dot delta V. So delta x dot m delta V I can write is greater than or equal to h upon 4 pi. Is greater than or equal to h upon 4 pi. Now this m, because it is having a specific value for whatever object we are going to talk about, so even we can write this expression as h upon 4 pi m. So this also is a relationship in which we are talking about change in position and change in velocity. What is delta x over here, guys? Yes, delta x is change in position. Hello Mohammed. Change in position, yes, and delta v is change in velocity. Okay, this is change in position and this is change in velocity. So basically change in position, change in velocity, or we can write, instead of change, we can also write uncertainty in position and uncertainty in velocity. So you can write change in position, change in velocity. Also what we can mention, change in position, not distance, because what you can relate, your electron want to be at a specific position, no, always it will be keep on moving. So we won't be writing change in distance, we'll be writing change in position. So either you can write change in position or yes, uncertainty in position as well. So what we can write, change in position or uncertainty in position. Okay guys, what we can write change in position or uncertainty in position also we can mention. And here also we can write change in position, change in velocity or uncertainty in velocity. So that also we can mention. So change or uncertainty, because this is Heisenberg's uncertainty principle. So change or uncertainty in position, and here change or uncertainty in velocity. So this is what we get the final expression. Okay, and because of this, guys, because of this, what you can relate, one of the concept which we used to study and which we used to believe is correct is going to rule out. So because of this reason, what it do, it rules out. Yes, what it do, it rules out the existence. Yes, it rules out the existence of definite, what, it rules out the existence of definite path or trajectories of electrons. Definite path or trajectories of electrons. Definite path or trajectories of electrons and other similar particles. Means what we used to say, that there is an orbit in which electrons revolve around the nucleus. So what it said it's not only, or like orbit is like we are saying it's a fixed circular path. No, there is no fixed circular path in which electrons revolves. Yes, so what you have to know, if there is no fixed circular path in which electron revolves, what it is going to be. So from here we'll be learning the concept of orbital. Yes, I'll be coming live on that also, Abhishek. So there will be a session today on hydrogen bonding, which is a very important topic. Hydrogen bonding plays a very important role in all the major concepts. So whether you talk about organic chemistry, inorganic chemistry, hydrogen bonding plays a very important role. So today there is a session at 6:30, right? That is for class 11. The special class is there in which we'll be learning hydrogen bonding. Okay, Abhishek? So if you want, you can join that as well. And everyone also, yes, all those who are here, you can understand today we'll be having a special class on our Unacademy platform, and that is on hydrogen bonding. The timing for that is 6:30 to 7:30 p.m. 6:30 to 7:30 p.m. there is a special class on hydrogen bonding, and trust me guys, hydrogen bonding, if you will be learning, you will be able to understand many of the topics like solubility, the major product in organic reactions, and many of the things you will be able to understand with the help of it. Okay, Abhishek, very good. So what we can understand, the Heisenberg uncertainty principle, what it do, it rules out the existence of definite path or trajectories of electrons and other similar particles, and this is what we can understand. And that is why Your Heisenberg and uncertainty principle made what? Orbit concept failed, and now what we'll be learning? We'll be learning about another, yes, topic, which is orbital. What is that? Orbital. Now in detail about orbital we'll be learning in next class, but what is orbital? Yes, Abhishek, Suman, Mohammed, just chill bro, Pranjal, everyone, Alka, you have heard about orbital? Yes, in 11th standard we might be learning first time, because we all are in 11th right now. Say Abhishek, you are in 12th, you must have heard about it in 11th standard. So orbital, yes, tell me guys, what is orbital? So orbital is nothing but it is a 3D space. What is it guys? It is a 3D space. It is a 3D space present in an atom. So it is a 3D space present in an orbit where the probability of finding an electron is maximum. So what probability of finding an electron is maximum? Now here I am going to make you understand a very important point, which is going to help you to understand many concepts later. So what we do, tell me everyone, we used to make the atom like this, no? And we used to make electron, we still make the electrons like this. In the first shell there are 2 electrons, second shell there are 8 electrons. We make it like a circle, right? Tell me everyone, we make like this only, no? The electrons, yes, but understand one thing, that your electrons are not present as a circle. They are not present like this, a single lump. They are present in the form of electron density, guys. What they are present? They are present in the form of electron density. So what electrons? Electrons are not present as this lump or circular form. They are present in the form of electron density or electron cloud. Electron density or electron cloud. So electron is not present like this, a circle or a lump. It is present in the form of electron density or electron cloud. Like suppose if I say in this shell I have to show the electrons, electron won't be present like the lump. It will be present in the form of electron density, or yes, it will be present in the form of electron density or in the presence of or electron cloud. So what we can relate, electron is not present just a specific circle. It is always present in the form of electron density or electron cloud. Now you must be getting one question also in your mind. If it is like this, like dot 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 dot, so how we'll get to know how many electrons are present in, no Suman, not nucleus, the electrons they are present, yes, in a shell or in an orbit in the form of electron density or electron cloud. So actually they are present in the form of electron density or electron cloud, not like this lumps the way we show. So what you have to know here, if they are present in the form of electron density or electron cloud, how you will get to know how many electrons are present? Because this dot 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 form, you cannot find out, no, that how many electrons actually are there. So how you find it out, guys, in a particular shell, how many electrons are there? So if a particular region in a orbit or a shell gives us the mass as 9.1 into 10 to the power minus 31 kg and charge as 1.6 into 10 to the power minus 19 coulomb, that specific region we consider as 1 electron. Or suppose in a particular region, if you are getting the twice of mass of, yes, electron and twice of charge of electron, you will consider there are 2 electrons in that particular shell. If you are getting 8 times of charge of electron and 8 times of mass of electron, you will consider there are 8 electrons, correct? So if electrons, yes, tell me guys, if electrons are present in the form of, very good, if electrons are present in the form of what, guys? In the form of this electron density or electron cloud, and it is moving also, guys. Now tell me, can you tell the exact position of electron? Yes, if it is in the form of this electron density, or electron is in the form of electron density and it is moving also continuously, can you tell the exact position of electron? Tell me everyone, can you tell the exact position and momentum of electron? No, absolutely not, correct? Because what you have to know, that Heisenberg uncertainty principle said the same thing only. You cannot find out the exact position and momentum of an electron at any given point, and because of that only the concept of orbital arised. So concept of orbital will be learning in the next session. So concept of orbital and little bit regarding quantum mechanics, what we'll be doing, we'll be learning in the next session. So make sure all of you guys, you are attending the next session too, and we'll be learning about concept of orbital, and it's going to be really interesting, guys. You will be understanding some new thing. Till now we used to learn all those things which Bohr said. Bohr said that okay, there is a nucleus, there are shells in which electrons are present, they revolve around the nucleus. All these things we are learning from like past 3-4 years, right, in the structure of atom. But we are going to understand a complete new thing in the next session, and it's going to be really interesting. So make sure you guys are attending that session too. So what we learned today, we learned about the quantum mechanical model of an atom after learning what are the limitations of Bohr model of an atom. So we understood there are some limitations of Bohr model of an atom, and due to that only another model of atom came into the picture to give us the correct idea about the structure of atom. Correct. So how we can understand about the correct idea of structure of atom with the help of quantum mechanical model of an atom. So it considered two results. One is dual nature of matter, which specifically discussed about dual nature of electron, and we learned about a de Broglie equation over there, how we can find out the wavelength, so what and all are the relations for it, that and all things we understood. Then we also did some numericals related to it. After that we learned the Heisenberg uncertainty principle. The Heisenberg uncertainty principle says that it is impossible to find out the exact position and momentum of an electron at any given point. So that we learned what is the mathematical expression for it, and yes, we understood that we'll be learning about the concept of orbital in the next class. And yes, this is what we have done. Now let me give you some information about our classes, guys. Yes, all of you. So talking about, yes, our classes, so all of you should know, guys, here we are learning the concepts, but if you want to do the fully fledged course, you want to do the complete exhaustive completion of the syllabus, what you have to do, you have to join our plus course classes. And if you want to join the plus course classes, today is the day, guys, because there is an offer today that you can save up to 41%. Yes, if you enroll for 24-month course, you'll be getting 6 months extension, and you will be getting, yes, around 41% savings you can do. If you enroll for 12%, like 12 months course, yes, you will be getting around 34% savings, and if you will be enrolling for 6 months course, your savings will be 29%. So for more months you are going to enroll for our plus course classes, yes, you will be getting more benefit, and for that you can use my code, which is MRIS10, and you will be getting instant 41% discount if you enroll it for a 2 years course. So that's what we can understand, and only 6 hours are left for it. Now talking about which and all ongoing batches are there for our plus course classes for ISC class 12 and ISC class 11. For ISC class 12 there is a batch going on, which is Achievers batch, which started on July 6th, and a new batch is also, yes, going to get started in the August. So from 4th and 5th August it will be started, so you can understand that, so you can join in the new batch as well. Very good, thank you so much, Abhishek. Now Achievers batch, who is taking the classes? I am taking chemistry. Biology is taken by Lakshya Gera sir, physics is taken by Mohana Thara ma'am, and maths is taken by Rahul Mohanani sir. And talking about the same for class, yes, for class 11 the batch is going on is Brahmastra, and in Brahmastra batch all the teachers are same, and we are together going to do the exhaustive coverage of syllabus. And again I'm telling, guys, because it's a big offer, you can get around 41% off on your Unacademy Plus subscription. So make sure you are enrolling for it. Yes, and yes, I'm introducing you about our community. So this community you can join on our Unacademy app too, guys. So there you will be getting all the information, yes, regarding the classes. You will never miss any update from your favorite educator. You'll be getting the session notes and practice material, and you can share your feedback directly with the educators via polls. Yes, and this is what we have done today. Thank you so much, Abhishek. Thank you, Suman. Thank you, everyone. So yes, we'll be meeting in the next session then, and we'll be learning about the concept of orbital. So okay, guys, So I want every one of you to join tomorrow my session at 2:30. Yes, at 2:30 p.m. in which we'll be learning how to ace class 12 chemistry. So we won't be learning any topic in tomorrow's session. We'll be learning all those tips and tricks by which you can get class 12 chemistry in a very easy manner, and you can score even your CBSE and ISC exam 100 out of 100. Many of my students, they have got this time in ISC as well as CBSE a very good score. So what you have to know, we'll be learning all those tips and tricks. So make sure everyone, yes, you are subscribing to our channel and you are pressing the bell icon so that you will be getting all the notification regarding the classes. So okay guys, so next class, Suman, we'll be having on the YouTube itself, we have a class tomorrow at 2:30 p.m. We have a class in which we'll be learning about strategies to ace class 12 chemistry. We'll be learning that, okay? And yes, we have a special class also, Suman, which is there on Unacademy app. Yes, which is absolutely free to join, and that you can join by downloading the Unacademy app, and you can choose your goal. And for ISC class 11, there is a special class in which we'll be learning hydrogen bonding. Okay, Suman? So on YouTube, there is a class tomorrow at 2:30 p.m. in which we'll be learning strategies to ace class 12 chemistry. And on the Unacademy platform, on Unacademy app, there is a class today at 6:30 p.m. which is a special class in which we'll be learning about hydrogen bonding. Okay, Suman? So okay guys, we'll be meeting in the next session then. Thank you all of you. Bye-bye. Thank you guys. Bye everyone. Thank you Suman, Abhishek, Veena, Prajal, Mohammed, everyone. Yes, Alka, thank you so much everyone. Bye-bye. Yeah, yes, I have to move little bit after the session. So yeah, thank you Abhishek. Thank you everyone. Bye-bye.